Hi everybody, I hope your day is going well and you are ready to review factoring polynomials. So we're going to review basically 4 different methods of factoring that we want to be pretty comfortable with. And we're just going to remind you what factoring means. So just as a make sure we're all on the same page here. So let's recall that to factor, like this word is very specific, and most math words that we use are very specific. So when we say to factor, it means to write something as a product. No matter what it is, it could be a number, like 10 equals 2 times 5, that's factored. It could also be an algebraic expression, which we're going to want to be able to do both. And the uses for factoring, there are 2 main uses for factoring. The first one is to simplify algebraic expressions because they are easier to work with when they are simplified. We are going to want to not expend a lot of mental energy on simplifying because we want to be able to focus that mental energy on the calculus. So the first use of factoring is to simplify, and the second use of factoring is to solve equations for the variable when you have them set equal to 0. And the reason for that is because if you have a product of 2 or more things and you have that product set equal to 0, so something like this, where those 3 boxes could be anything, then one of these boxes has to be 0, because you can't multiply numbers together and get 0 out unless one of those things is 0. So factoring is the best tool that you have to solve things like that. Okay, the first method that you should use to factor, and it works on anything at all, no matter how many terms there are, and you'll see our other methods kind of depend on how many terms that you're working with. The first method is factoring out the greatest common factor, or the GCF. I reviewed this a little bit in the previous section, so I'll go through this kind of quickly. In example number 1, we have a trinomial, so this has 3 terms in it, and it's a 6th degree. Okay, the highest power is 6. So you look across the minus and pluses at each term, and you look at the numbers. We've got 12, we've got 6, and we've got 3. And you want to think of what is the highest factor or number that can be removed or divided out in each of those 3 numbers. And that, of course, is 3. So that's part of our GCF is 3. And you look at the powers of x. We've got x squared, x to the 4th, and x to the 6th. And the largest x degree that can be removed from both, all 3, is x squared. Okay, then what we have left from this first term will be a 4. Then we've got minus, okay, the second term here, we factored out a 3, so we've got 2 left. We factored out x to the 4th, so that'll be x to the 2nd left over. Then in our last term here, we factored out a 3, so we have a 1. And then we factor out x squared from x to the 6th. And remember, we're dividing by x, basically 3x squared here. So you don't divide the power 6 by 2. We're dividing x to the 6th by x squared. So you're going to subtract their powers. So we'll have x to the 4th here. And there we go. Here is the factored version of that trinomial by taking out the GCF. Example number 2 is 4 squared of x plus 2x minus 6x squared. Now, generally, as you're working with anything involving radicals, you want to consider rewriting that in exponent form first. So I would definitely say that let's rewrite that radical x as 4x to the 1/2 before doing anything further. All right. Now we just have some numbers times different powers of x added and subtracted. So we're going to look at the numbers first. We've got 4, 2, and 6. We can factor out a 2 from all of those. Then we have x to the 1/2, x, and x squared. The highest degree that occurs in all three of those, remember this is a to the first, so the smallest power we have is 1/2. So we can only take out an x to the 1/2 here as our GCF. Okay, taking out 2x to the 1/2 from 4x to the 1/2, that gives us 2. Okay, dividing out 2x to the 1/2 from 2x, we'll just have x to a power. Okay, we've got x to the first over x to the 1/2, so we're going to subtract their powers. 1/2 minus, 1 minus 1/2 is 1/2, so we'll have x to the 1/2 here. And then lastly, we took out a 2 from the 6, so I'll have the 3. Okay, we factored out an x to the 1/2, so we're dividing by x to the 1/2 here, by 2x to the 1/2. So we're going to cancel x squared and x to the 1/2 by subtracting their powers. All right, I don't know, 2 minus 1/2 is 1.5, right? And that as a fraction is 3/2. Here we go. This is our nicely factored version by taking out the GCF. All right, last example of GCF here, we have, well, it looks pretty complicated, but again, we just kind of want to see what's the same, right, and what's different. So we've got a big chunk of stuff here. We've got plus another big chunk of stuff here. So we're going to want to look over this plus to see what's in common to factor out. Okay, same basis, x plus 2 squared, and then x plus 2. Okay, so the largest thing, degree of x plus 2 we can factor out is x plus 2 to the first. Okay, then we have another, similar, same base situation with the x minus 2. So let's see here, we've got x minus 2 to the fourth and x minus 2 to the third. So we can take out an x minus 2 to the third. Okay, now what we have left over, okay, it looks like here we took out, we'll have an x plus 2 to the first left because we only took out an x plus 2 to the first. And here we'll have an x minus 2 to the first left as well, times the x plus 2 factor because we took out x minus 2 to the third. So here we're going to have x plus 2 times x minus 3. I'll just move that over a little bit. All right, then we have plus, and that's this plus here, this plus here, this plus. Now looking here, this actually was, oh, look, that is our GCF, right? So we're just gonna have plus 1 because everything got factored out. Okay, now the GCF here will always just stay factored, but you want to look and see, is there anything you can do here to simplify? And you might say no, but the answer is yes, because if you FOIL or multiply or distribute these out, iPad, come on, I don't know why it's so laggy, every time, then what we can do is combine with the plus 1 in that set of parentheses. So let's see, x plus 2, still not caught up yet. And planned obsolescence, I don't know, my iPad isn't even that old. So I'm just working on, oh, there we go. I'm just working on multiplying, these two binomials. We have x plus 2 and x minus 3. So let's see, first is x squared. Okay, outer is negative 3x and inner is positive 2x, so it'll be minus 1x. Then we have the last, which is 2 times negative 3, and so that's minus 6. Then we have plus 1. As you can see here, it's a small thing, but it's a thing to do nonetheless, that we have negative 6 and positive 1 that we can definitely combine together. Let's see, x squared minus x, and then combining those numbers gives us negative 5. then the last thing you'd want to do is see if you could factor that x squared minus x minus 5, this part here, and I don't believe we can. And so anyway, we'll review that, how to factor that in just a couple minutes, but so here's our factor form. All right. So that's the first thing you should look for when you're factoring, is to take out a GCF. Works with anything at all. The second thing that's kind of easy to spot is if you have a polynomial with 4 terms in it. When that's the case, the method that you want to use is called factoring by grouping. Okay, so I'll remind you how that works by way of these 2 examples. So for our first example, let's look at x cubed plus 2x squared plus 2x plus 4. Okay, so you can see we have 4 terms here, the x cubed, the 2x squared, the 2x, and the 4. And so what we do is you look at the, see if there's a GCF first, and there's not, so we can't factor out a GCF. What you want to do is group 2 groups of 2. If they're written in order of, decreasing powers, then you group the first 2 together and the last 2 together. Then you look for a GCF of each of the groups of 2. Okay, so x cubed and 2x squared have the greatest common factor of x squared. Then 2x and 4 have a greatest common factor of 2. Okay, so then we take the GCF out of each group. Okay, so I'm factoring out an x squared just from the first group here. So that'll be have me left with x and then plus 2. Okay, then we have plus the second group of 2. I'm factoring out a 2, so from here. And what we're left with when we factor out a 2 is x plus 2. And if we're lucky, if this method is going to work, the thing in the parentheses has to match. Okay, so we've got x plus 2 and x plus 2. The very last step to factor with factoring by grouping is to factor out, now in this case, the x plus 2 over this plus here. Okay, so we're going to take the x plus 2, the x plus 2, they're going to come, it's going to come out to the front, and it's going to be multiplied by what's left over. So we have x squared and then 2. So this will be x squared plus 2. And there it is factored. X plus 2 can't factor further, x squared plus 2 can't factor further, and so this is its fully factored form. Okay, let's try one more example. I encourage you to pause this and try this on your own before I show you how to do it. If you're not sure, you can also follow along with me. All right, so we've got 4 terms here. There is nothing in common with the GCF to take out, so factoring by grouping is a really good thing to try. So we're going to look at the first group of 2 and the second group of 2, and we're going to look for a GCF. In the first group, it looks like 4x squared is our GCF. And in the second group, it looks like we have a 3 as our GCF. But whenever we have a minus in front here, the signs can get a little bit weird. So what you want to do is include the negative sign in your GCF. Whenever this kind of like sign in front of the third term is a negative sign. So we're going to include the minus with the 3 greatest common factor. You'll see what happens when we factor it out and why that's helpful. Okay, so we're going to take out a 4x squared from the first group of 2. We're left with x plus 1. Then we're factoring out a negative 3, so this will end up being minus 3. And when we factor out a negative 3 from negative 3x, right, we're just going to be left with positive 1x. And when we factor out a negative 3 from minus 3, the sign's going to change. Again, we'll have a +1. Okay, if we didn't have the negative in the greatest common factor there, then we would be left with a set of parentheses here and here that don't match. Okay, so you know what to do here. Take out, we're going to factor out here now the x plus 1s. Okay, so these are going to come out to the, we're going to factor out that in the front. So we'll have x plus 1 multiplied by what's left over here. We'll have 4x squared. And then minus 3. And there we have factored that thing. So there it is in its fully factored form. All right, polynomials with 4 terms have a special thing to do. Polynomials with 2 terms also have a special thing that you can look for. And that is the difference of 2 squares. Difference of 2 squares. And so maybe I'll remind you like of what that means. So if you have something that is, let's use x and y. So we'll do like x, what am I saying here? 2 squares. So x squared minus y squared. Okay, difference minus 2 things squared. The way that that factors is really kind of nice. You get the first thing, the square root of the first thing in the first part of the set of parentheses, so like x and x. You get the square root of the second thing as the second part of the parentheses, and then we have one that's a plus between them, and then one that's a minus. It's kind of got this cute little like symmetry going on there. Okay, so for example, x squared minus 25. Well, that is a difference, of course. It's got 2 terms, and 25 is a perfect square, as is x squared. All right, so this is going to factor into x plus 5, x minus 5, or x minus 5, x plus 5. Doesn't matter the order. And there we go. There it is in its factor form. All right, 81 minus x to the 4th. Now it's helpful if you know what the perfect squares are, especially like up to 100. So 81, of course, is 9 squared, and x to the 4th is actually x squared squared. All right, so this is a difference of 2 squares. So let's see, we're going to have 2 parentheses. We'll have 9 and 9. And yes, the order matters. So 9 comes first. X squared plus minus. Okay. And if you remember, we always want to factor as kind of far as we can. So here we have a sum of 2 squares. That can actually never factor. So this one is fully factored. That's good. But here we have actually another difference of 2 squares, right? 9 is another perfect square. So that's going to factor a little bit further. 3 minus, well, I'll stick with my format, 3 plus x, and then 3 minus x. There we go. There it is in its fully factored glory. All right, number 3, we have x minus 3 parentheses squared minus 16. I'm just going to move this over a little bit. Okay. So again, 16 is one of those perfect square numbers. So we have that. We also have x minus 3, and it is squared. So this is, it's kind of weird looking, but this is actually a difference of 2 squares. Okay, so how this is going to factor is exactly the same, right? The square root of x minus 3 squared is x minus 3. So we have that here and that here. And then the square root of 16 is 4. So we'll have 4 and 4. We'll have 1 with plus and 1 with minus. Okay, now there's not much to do here to simplify, except we should definitely combine those numbers together. Like, we've got minus 3 plus 4, and so that's plus 1. Then we've got minus 3 minus 4, and so that's minus 7. And there that is in its fully factored form. Okay, last one here. We've got 9x squared minus 36y squared. Okay, 9 and 36 are also perfect squares. Okay, so we have 9x squared. This is really like 3x whole thing squared. Okay, so that'll be the first in the first part of our parentheses here. And then 36y squared, that is actually 6y whole thing squared, right? So we'll have 6y, 6y, 1 is plus, and 1 is minus. So there we go. All right. Polynomials with 3 terms are, I don't know, like more difficult, I guess. So there are a couple different ways that you will want to be familiar with when you're factoring polynomials with 3 terms. Okay, 2 methods in particular that depend on, and which one you use depends on what the number in front of the x squared is. So, we've got this or here. So the first situation is when you have an x squared term that does not have a number in the front other than 1. So if you have 1 x squared plus, I'm using b for any number, bx plus c for any number, then I don't know what to call this, I'm just going to call it reverse FOIL. So you'll see what I mean. We've done this already together. And then the second method is if you have a number in front of the x squared that is not 1. So in other words, so ax squared. Okay, in that case, you're going to use what's called the AC method, and I'll review how that works. Okay, so for our first example, let's look at x squared plus 3x minus 10. So this fits into, of course, this situation. So we're going to factor into, these, you set up your parentheses, we've got x, and then we look for 2 numbers that are going to, what do we need? They need to multiply to -10, and they need to add up to +3. And I think there are numbers that work +5 and -2. And so here it is. That's it. That is how to factor something like that. All right, example number 2, we have 2x to the third plus 18x squared plus 40x. Now this does not look like, we have up here. It's to the third power, so of course it doesn't look like that. It also doesn't look like this because it's to the third power. But if you notice, there is actually a greatest common factor that you could take out of each of the terms. Okay, so don't forget that that's a really useful thing to use or to look for whenever you're factoring anything. Just always look for a GCF. Okay, so we could take out a 2, and we can take out an x to the first power, I believe. Okay, so here's a GCF. So what we have left over then is x squared plus 9x plus 20. So now here we have a lovely quadratic that now fits this form. Okay, so we're going to want to try to reverse FOIL that. So we're going to set up our parentheses. We've got x, and we're going to look for 2 numbers that multiply to +20 and add up to +9. And I think that those numbers exist, and we've got +5 and +4. Okay, so here we go. All right, example number 3 is 6x squared plus x minus 15. All right, so on first glance, I hope it's easy for you to see that it does not fit this form, right? Because we've got a 6 in front of the x squared. So it does fit this form. Let's just see if we can take out a 6 and make it a 1. Right, this is 6 here, we've got a 1 here, we've got a -15. Nothing to factor out there. So looks like we're forced to use this AC method. So what is the AC method? So what we do, I'm going to write kind of like the steps over on the side here. So the first thing you want to do is find A times C. Find what A times C is. All right, so in this case, refer to this is A, this is B, and this is C. Okay, not the x squared or the x, just the numbers, the coefficients. Okay, so we have 6 and we have -15. Okay, that gives us -90. Okay, once you have that number, you look for numbers that multiply to A times C and add to B. So we need numbers that multiply to -90 and add up to, in this case, B is 1. And I think that we do have numbers, right? 10 and 9 go to 90 and they're 1 apart. We need them to be opposite signs to multiply to -90. And we need the 10 to be positive so that they add up to +1. Right? So we have +10 and -9 are our numbers. All right, then what you want to do with those numbers is split up your B term, or that middle term, the 1x, into 2 terms using the numbers that you found. Okay, so we'll call this like split the bx term using these numbers. All right, so what that's going to look like is 6x squared plus 10x minus 9x and then minus 15. Okay, so so what we've got here, this is the b term, really, like the 1x that we're splitting up using 10 and -9. Okay, now what we've done is we've created something that's got 4 terms in it. Right, so how we factor something with 4 terms in it is by grouping. Factor by grouping. So let's remember what that means. We're going to take, we've got 2 groups of 2. Okay, so first group, second group. Find the GCF of each group. Okay, 6x squared and 10x, GCF will be, what, 2x? Okay, -9x and -15x. Remember, we want to take the negative with our GCF, so it's going to be -3. That's the biggest number that goes into both 9 and 15. Okay, so then we're going to take out the GCF of each of these here, so we'll have 2x. Okay, we'll have 3x left over, I believe, and then plus 5. Okay, then we took out -3. Everything's going to change sign here. We'll have 3x. And now plus 5. Okay, keep on going here. It looks like we're on the right track, right? We've got 3x plus 5 in parentheses. The same here, so we're going to factor out the 3x plus 5. And what we're left with is 2x minus 3. And there it is. There it is, the factored version of 6x squared plus x minus 15. Now, if you know how to do this, how to factor something like this by trial and error, you can totally do that. But using this method will always get you there, so it's totally up to you. So why don't you pause this and try number 4, 4x squared plus 15x plus 9. So the first thing we want to do is find A times C. Okay, so that gives us 36. And I guess implicitly in my mind, I'm thinking like, well, we've got a 4 here, but I can't factor out a 4 from 15 and 9, so we're forced to use this method, right? So we've got 36. We want to find 2 numbers that multiply to 36, or 2 factors, 36 that add up to 15. All right, so, 15 is 3 and 5, but those or no, wait, sorry, 36. We have 9 and 4, but those don't add up to 15. We've got 3 and 12. I think those will work, 3 and 12. Okay, so then we rewrite this, right, by splitting up the middle term into plus 3x, plus 12x, and then plus 9. Okay, so here's the middle term here, the 15x, we're just splitting that up. Right, then we go factoring by grouping. So here we've got two groups of 2. Factor out the GCF of each. In the first case, we've got x. In the second group, we've got a GCF of 3, I believe. And so let's pull out an x in the first group of 2. So we've got 4x plus 3. In the second group of 2, let's pull out a 3. And okay, this is looking good. We've also got 4x plus 3. And then lastly, we're going to factor out 4x plus 3. And there's our fully factored version of the quadratic that we were given. Hey, Steve, it's kind of fun, I think. Okay. So, factoring is, I hope, enjoyable in some way. It can be a little, you can get lost in the flow state or whatever as you're doing math, which I hope you can find that throughout the semester at least once. So the second kind of reason why we like to factor, why we want to be able to, second of the two uses that I told you before, is for finding solutions to equations set equal to 0. Okay, so finding, in other words, the roots or the zeros of something. One way to do this is by factoring. And this works on anything. Not necessarily like a quadratic. I mean, it does, but it works on anything at all. Okay, you can factor something and solve each of the factors by setting equal to 0. Alternatively, you could use the quadratic formula, of course, if you have a quadratic. So in other words, ax squared plus bx plus c equals 0, and you want to solve for x. So if you're solving this, you can use the quadratic formula. So I'll remind you what the quadratic formula is right now. So if you, I learned this using the Pop Goes the Weasel song, right? If you, for some reason, did not learn that, well, your teacher did not tell you that, you should go YouTube quadratic formula song, because it's a really, it sticks with you. It's a really easy way to memorize this. Okay, so what it does again is it solves this equation for x. So let's say if solving for x, of course. Okay, here is what the quadratic formula says. It says that x equals negative b plus or minus the square root of b squared minus 4ac. That's all divided by 2a. All right. I'll go through one example with factoring and finding roots, and then I'll go through an example using the quadratic formula. So let's find the roots or the zeros of x squared plus x minus 42. So basically, when you want to find the zeros, you're setting the expression that you have equal to 0, and you want to solve for x. Okay, so let's try to factor and well, see if we can factor it. That would be the first thing I would try. So can you factor? Right, we don't want to use a quadratic formula if we don't have to. So this is, have a 1 in front of the x squared. So let's see if we can find two numbers that multiply to negative 42 and add up to 1. And I think we have those positive 7 and negative 6. Okay, so we have a product of two things, this thing and this thing. If you're going to multiply this together and get 0, one of the factors has to be 0. Okay, there's no other way to get 0 with multiplication unless you multiply by 0. So there's two x values that you can plug in here to get 0 out. So this, factor here is 0 when x equals -7. Okay, and then this factor here is 0, x minus 6 is 0 when x equals 6. And so here are the two zeros, or the two roots. All right, let's look at 2x squared plus 5x minus 3. We're going to find the zeros, so we want to set this equal to 0. Now looking at this one's going to be a little more complicated just because we don't have a 1 in front of the x squared and we can't factor out a 2 to get a 1 there. So you have options. You could use the AC method to try to factor this. And I encourage you to do that as a little exercise if you want, but just as an exercise in reviewing the quadratic formula, I'm going to just jump straight ahead and use that. So as an option, you can use the AC method, or you can use the quadratic formula. All right, so the quadratic formula would say, all right, so let's see, we've got to figure out what A, B, and C are, right? So we have A equals 2, we have B equals 5, and we have C equals -3. I just want to plug that in, all those numbers into our quadratic formula right here. So take a sec to write this down. Make sure you have all the variables, or the numerical values in the right spots. So we'll have -5 plus or minus the square root of 5 squared minus 4 times 2 times -3. And that's all over 2 times 2. And you don't want to leave your answer this way. Definitely simplify. So I would recommend you simplify what's under the radical first. Okay, so let's see, 5 squared is 25. So let's see, we've got 25. -4 times 2 is -8. -8 times -3 is +24. 2 times 2 in the bottom is 4. Hello, iPad. Welcome to class. Are you still with me? See, it's trying so hard. Okay, there we go. All caught up. Now inside of the radical, we have 25 plus 24. I think that is 49. All right, 49 is a great perfect square. So actually in this case, we have some nice numbers to work with. A lot of times quadratic formula can give you irrational numbers. In this case, we won't have that. Okay, so we've got -5 plus or minus 7 over 4. Again, you don't really want to leave your answer this way. I mean, you want to get two different numerical values. So you figure out what happens when you take the plus, and you figure out what happens when you take the minus. Okay, so we're going to have two x values. Okay, we're going to have -5 plus 7 over 4. Okay, so let's see what that is. -5 plus 7 is +2. Okay, so that's 1/2. Then we look at the other x value, so that'll be -5 minus 7 over 4. -5 minus 7, that's -12. And so that gives us -3. So we've got x equals 1/2 and x equals -3. And these would be our two zeros or roots. Okay, so I mean, we're gonna be, practicing this kind of technique with factoring and setting things equal to 0 to solve for x a lot. There'll be more interesting reasons to do that as we learn some calculus things, but for now, I hope this was a good refresher. So in section 8.5, which is our well, almost our last section for review. Oh, no, it is our last section for review, yes. We will talk about fractions, how to combine fractions together, getting common denominators, and then also rationalization. So tune into that video and have a good day.